All right. Well, thank you everybody so much for joining. My name is Scott Bugg. I'm here with AVAP, and today we're super excited to be sharing with everyone how we can begin to develop data-driven strategies for boosting enrollment and retention by using Snowflake as a cloud data platform and by developing Streamlit applications within Snowflake. Got a lot to talk about today, so I'm going to go ahead and jump into our agenda. First, I'm going to talk a little bit about who we are at AVAP, what sort of work we do, who we are as a company, and then we'll really dive into talking about Snowflake as a cloud data platform. We'll talk about how it can be applied in the higher education space and really talk about all of its wonderful functionalities and features. From there, we'll touch on student enrollment and retention, talk a little bit about the current climate, some of the challenges we're seeing. And then from there, we'll really talk about how we can leverage data analytics, especially through the use of Snowflake, to identify and start to begin to develop the strategies for boosting enrollment and retention. And then from there, we'll dive into the cool stuff. We'll open it up to the team, and we have a few demos of Streamlit applications that we're super excited to share with everyone. Then after that, we'll go ahead and open it up to the floor for a Q&A session so that we can answer any of your questions you may have about Snowflake, the Streamlit applications, or even us at AVAP. So here is our team today. We have Stacy George, a senior consultant, Haley Miller, a consultant, Scott Bugg, senior analyst, and Amanda Chewy, an analyst. So let's talk about us at AVAP. Since 2001, AVAP has really specialized in helping businesses meet their goals and transform their organizations through a variety of service offerings and solution partners. We are an industry-focused technology, management, and advisory service partner, and really known for being able to implement complex technical solutions and provide exceptional customer service on top of that. We are headquartered here in Columbus, Ohio, and have customers and offices across the country. Here at AVAP, we really have a solid wealth and good group of consultants with a deep experience in the higher education space, as well as other industries such as nonprofit and government. When looking at some of our customer success stories, we have a variety of institutions in the higher ed space that we've worked with, both large and small. We have large ones such as the Ohio State University and the University of Georgia, and even smaller institutions like Broward College or Hines Community College. In terms of our service offerings here at AVAP, not only do we offer a depth of services in the data analytics and AI space, but we also offer a breadth as well. On top of the data and analytics offerings, we also offer organizational transformation solutions such as project management, business analysis, and process design. And we're also a Workday sponsor. So that means we are fully integrating the Workday and implementing the Workday platform and have the functional and technical expertise to pair with that. So now we're going to talk about one of our solution partners in Snowflake. So for those who are unfamiliar with Snowflake, Snowflake is a cloud data platform that not only excels at being able to store a variety of types of data all in a single location, but Snowflake also allows you to perform a variety of workloads on top of this data, all in a single location. So what's that mean in the higher education space? Well, when we think about the data we're going to have available to us, right? Whether that's on potential donors, students who are looking to enroll, grades, advising reports, housing information, that's all going to probably be coming from different source systems, and that data is going to be siloed. But with Snowflake, we can take all the different data types from these data sources and store them in a single location. Then once we have our cloud data warehouse or data lake set up, we can do stuff on top of that data to really drive the value out of it. So we can set up our data pipelines, data exchanges, we can perform data science here, and even, as we'll see later through the use of Streamlit, develop data applications. Then when we think about those who are consuming the data, who needs access to data, Snowflake also is an excellent platform that enables us to do so. Whether that's making sure our data is up to date, looking for real-time analytics, running simple SQL queries, or even generating our operational reports, Snowflake can do it all. Snowflake also is great with advanced analytics and AI, and even allows us to develop machine learning models, which can produce predictive insights. In terms of architecture, Snowflake is a SaaS-based solution built on top of the three major cloud providers: Google Cloud Platform, Amazon Web Services, and Microsoft Azure. One key benefit of Snowflake is that it is a fully managed service, meaning that you and your team don't have to worry about the infrastructure aspect of the platform. Any sort of maintenance window or upgrade, that's all taken care of by Snowflake on their end. This really allows you and your team to spend the bulk of your time really trying to get that value out of your data. Another key aspect about Snowflake is that it separates the compute aspect from the storage aspect and really allows you and your organization to scale these on the fly as your needs change. And these are also priced separately, meaning that you and your organization don't have to worry about ever overpaying for what you don't need or eventually won't use. So with robustness in being able to store a variety of data sources and performing lots of workloads on top of that, and providing simple but effective and secure data access, Snowflake really does it all and is such a powerful data platform. So now let's talk a little bit about higher ed, enrollment and retention. So of course, any institution, is going to have some sort of central goal, right? That wants as many students as possible at a sustainable rate to enroll at their institution, right? And of course, once these students are here, we're going to want them to complete their educational journey all within the same place. Any institution is going to want a way to boost their revenue, and so it's only natural to look at student retention and enrollment as growth opportunities. And for good reason. On average, about 16% of revenue for public institutions is tied into student enrollment and retention. That number is actually going to jump up to 19% for private nonprofit institutions. So clearly we have a good amount of our revenue here tied to enrollment and retention. So hopefully if we can find and develop strategies, ways we can boost these numbers, we're going to see a good return in terms of our revenue. But it's not always straightforward. Unfortunately, across the board, we're seeing that this area has really become a challenge for many institutions. Across the board, enrollments decreased at a rate of about 1.5% since 2011, and the nationwide average retention rate is sitting just at 78%. So clearly we see, a lot of institutions, we're going to have room for improvement here. But that's okay, right? That's why we're holding this webinar. We're looking for ways that we can improve upon these. So when we think about what is impacting enrollment and retention, I think it's only natural for us to want to first look at just the academic factors, right? We're dealing with, students here at a higher education institute. So of course, academic factors are going to be at play here. But again, we are dealing with individuals here, students. So we really need to be fair and paint a holistic view of who these people are so that we can fully understand them, fully understand our institution and the trends that are taking place here. That way we can begin to create our game plan. So it's important that we also consider not only the academic, but also the financial, social, and demographic aspects as well. Now you might be thinking, okay, great. We know we need to consider all of these areas together, but kind of how are we going to do that? How are we going to tie all of these things together? Well, the first thing is we need to start looking at the data. And the good news is that at any higher education institute, we're going to have a ton of data available to us, right? It's all going to be there somewhere, maybe not necessarily in a single location, but it's out there. Again, we're going to have data about students, where they're living. Are they maybe working a student job? Their advising reports, notes, financial aid background, applications, all of that, that's going to be out there. And this is great because this is really where we're going to be able to find out where, we have risks and or opportunities for growth in the enrollment and retention space. And if leveraged correctly, the data can help us to really provide those actionable insights in terms of developing strategies here. Once we're able to, develop those strategies, then we'll be able to implement those across the institution and really see that revenue drive up. But okay, we don't always know exactly what data we want to use, and there's a ton of it out there. And unfortunately, for many institutions, that data is going to be siloed, right? It's not all going to be in a centralized place, a centralized platform. So this is going to cause some problems, right? So if we want to be able to generate those, actionable insights, it's going to seem like quite a daunting task, really. And again, we know we want to be able to generate a holistic view of a student's educational journey. But when we try to do that with data that's siloed, it's going to be hard to link student data across disparate sources. And if we want to think about being able to, do some sort of advanced analytics in terms of developing strategies here, whether that's developing a model that could, forecast how many students of our, new applicants are actually going to enroll, or some sort of model that helps us identify students that are at risk of unenrolling. If we want to consider this with siloed data systems, it's going to be quite a challenge. So hopefully what I've been talking about here in this slide kind of paints this picture in your head, right? Again, we have all of these siloed data sources pertaining to different aspects of our university. And, we're going to have different research and reporting teams accessing this data, right? Trying to do something with them. And then we're going to be using different reporting tools on top of that. So in terms of being able to develop strategies here, this is not really the route we are going to want to go. First off, this setup is certainly going to be difficult to govern and manage because we have different teams accessing different systems for different purposes. Additionally, it's going to be pretty time consuming, right? If we have to hit all of these different source systems to pull the necessary data we need. Linking a single student's data across all of these sources is certainly going to be a challenge if that data is not in a single location. And again, that's only going to hinder our ability to really accurately portray a holistic view of a student's educational journey here. We also don't really have consistency when we're thinking about how these research and reporting teams are going to be interacting with each other. If we don't really have a centralized data platform to do that, we're going to see there's probably going to be some sort of inconsistent metrics and reporting methods here. And again, just duplicative work. And if we really want to think about implementing some sort of AI, advanced analytics solution, it's going to be even more of a challenge. So, okay, this is where Snowflake is going to come back into the picture. With Snowflake as an enterprise data platform, now we can house all of the data from these disparate systems all into a centralized location. This is great. Now our reporting teams, our research teams, those who are developing our strategies to boost enrollment and retention, all are going to come into a single location to do so. So if we just want to run some ad hoc SQL queries, great, we can do that in Snowflake. In the same location here, we can build out our data applications, as we'll see here in a bit. If we have a team who wants to do some sort of advanced predictive modeling, they can do that in Snowflake and don't have to bug other research and reporting teams to, get their data and have them do things on their end and then find a way to integrate that into a separate platform. No, with Snowflake, we can all do that in our same cloud data warehouse. If we do need to use some sort of external tool to access data, Snowflake does allow for that in a simple and secure fashion as well. So With this setup, we've knocked down data silos so that we can ultimately paint a holistic view of these students and our institutions. That will then allow us to really be able to develop these strategies to boost enrollment and retention moving forward. So we're nearing the point of kicking off our demos, but first I want to talk a little bit about this graphic right here. As we work through some of these demos, they're going to increasingly get more sophisticated, but with that, there's going to come a greater impact, right? We can almost think of this as a crawl, walk, run model. So the first couple of applications we're going to demo with everyone are two dashboards in Streamlit. And these dashboards really show the power of Snowflake in that we can take all this data from disparate systems sources and compile it together. Now that it's all in a single location, we don't have to, reach out to different people and different teams, which could take, weeks, months just to get it together in some sort of report. With these dashboards, now we can generate these holistic views in a single location and quickly get a snapshot view of the current state of either our student body or our institution. Then, as we get a little more sophisticated, we'll move on to the natural language query application. And this is going to start to incorporate some of that advanced AI that Snowflake is so good at handling. With this application, not only do we now have all of our data in a single location, but we can do stuff with it. Now we can answer questions on that data. So even if you're an unfamiliar user, if you don't necessarily fully understand how all of this data is getting into a same platform, maybe you're familiar with the student financial aid data, but aren't necessarily familiar with like the applicant's data. That's okay. With the natural language query application, we can simply type in a question about our data, and the application is actually going to spit us back out an answer based on the data we have in our system. And then in terms of the most sophisticated but most impactful application we have here for developing strategies, game plans, we have a predictive model that's going to take historic and past student records, those who either graduated or dropped out. And we're going to train a model based on these historic records so that we can look at current students and assign them a score on how likely they are to finish out their educational journey here at a institution. Now, before we kick off these demos, I want to preface it and say that we build all these applications out with student retention really in mind. However, these could just as easily be applied to student enrollment just as easily applied for student enrollment purposes as well. And that would really just require, switching some of the back end to point to different data tables. And then in terms of the predictive modeling, that model would also need to be trained on different variables as well. So with that, I will go ahead and hand it on over to Amanda, who is going to kick off our demos.
Thank you, Scott. So let me go ahead and pull up my demo. Okay, so the first solution we built is the overview dashboard, which is built in Snowflake by leveraging Streamlit. So at the top here, we have 3 filters that you can filter the data by. We pulled data from our Workday data tables, which consists of many different tables, such as departments, programs, and students. And these filters up here allow us to view the data specifically for what we need. So we can filter by departments, we have different programs, and we also have different degrees. And in this instance, let's go and look at the psychology department. And we see that all the data below has changed and updated based on our filter. If we were to just leave these filters preset at all, we'll get a holistic view of the entire institution. Here in the center, we have the graduation rate metric. This main KPI is listed first, so at first glance, you get this right away. Scrolling down, we have these 2 graphs. On the left, we have the financial aid trends that allow us to see financial aid data throughout different terms. And we can see that we have student loans always a higher amount compared to grants. And on the right here, we have enrollment versus graduation data. We see that the enrolled students decrease throughout the different terms, with summer only having minimal to 0 students. And we can see that the cumulative graduate students graph reflect that. So these two graphs are placed here for us to be able to highlight patterns at a glance. Scrolling down to this next section, this is still affected by the 3 global filters at the top. So all this data down here is still showing psychology data only, but we added this additional filter here where we can see the data by different terms, just to give us another dimension to drill down into. So go ahead and select spring of 2019. And as we see here, all the data below this filter updates based on the term we selected. Again, in the center, we have the 3 main KPIs: attendance rate, number of enrolled students, and the average financial aid given per student. And for this graph, we have a gender breakdown that makes up the psychology department students. And on the right here, we have a grades distribution that allows us to see the academic performance of these students. So in summary, this overview dashboard allows us to get high-level insights on an institution's current state. Now back to Scott.
Thanks, Amanda. All right, so the next application we'll be demoing is going to have a similar look and feel to the one Amanda just demoed. Again, this application is going to be built out using Streamlit within Snowflake. And really what it is a student dashboard that really allows us to drill down to a variety of levels. And this is going to compile not only a holistic view of a student, but we can also look at term and individual class data as well. I know I've been harping on this, but again, we can compile that holistic view of a student here. So not only will we have like grade data and attendance data, which would typically be stored maybe in one application or one system like Canvas, for example. But this also will hold extracurricular and financial data as well. So a real benefit here is that we don't have to go to different applications, different websites to view this. It can all be viewed within one place. And then this is also going to allow us to just quickly identify some areas of concern for students who look like they may be at risk of dropping out. So here is that application. So again, similar look and feel to our overview dashboard here. First, we're going to have a filter that lets us, oh, let me make sure that I'm sharing. There we go. So our student dashboard, again, gonna have a similar look and feel to the overview dashboard here. Have a couple filters at the top. So our first is selecting the program that we want to view students within, and then this is actually going to populate this list of drop downs. So when we change from business administration to computer science, we'll see that that filter ultimately populates a new list of students that we can filter on. All of the students within this dashboard are past students, so they either have graduated up to this point or are no longer enrolled at the institution. Right off the bat, again, tying together many types of data from different sources. So we have financial aid information here, their average per term. We see their extracurricular activities here. And then now getting in more of a term by term basis, see their attendance over time. Hopefully, again, this can help us to identify trends within certain students and certain programs as they progress through time. Some more KPIs on this student. So we see their average attendance rate, GPA, overall financial aid, and credit hours. Right now, this is showing across all terms, but we can actually filter that and drill down into single terms, which is nice too, having varying levels of granularity here. And so this will generate a couple of visualizations. We have, almost like a transcript type view here for students, course, term, grade, and credits, and then attendance by class. And then if we want to drill down even further, not only can we see how often this student was present for a given class, but we also have the ability to see how they attended class throughout that term. So right now we're looking at the student's software engineering attendance, and now we can change this and see how they attended class for their web development class. So again, with this application, not only do we have our just typical grades and reporting information, but we can also tie in financial aid and extracurricular aspects from disparate data sources as well. Next, we're going to have Haley, and she is going to present on our natural language query app.
Thanks, Scott. So as we've discussed sort of in the progression of our development, we wanted to give users the ability to actually ask questions on their data directly. And more specifically, the dashboards had a great way of visualizing certain data points. But say a user's questions aren't necessarily answered by those data points, we wanted to be able to give a user the experience in order to get the answers that they need. So ultimately, the natural language query application allows users to easily access their data, which is stored internally within Snowflake. And it synthesizes information from multiple different tables. So to Scott's point from earlier, even though data sources can come from a variety of different places, they all land within Snowflake and are then able to be synthesized together for use within the application. And we're actually going to leverage AI to explore the student enrollment and retention. And by doing so in Snowflake, we're able to use AI securely and not risk any compromise with the data security. And we're also allowing non-technical users to answer data-related questions simply. So sometimes I know people might have questions about the data, but might not have the skill set to use it. This application works to address sort of the gap in knowledge there. So let me pull it up. Okay, so right here we've landed on this page. And this question, what are some of the examples of questions I can ask, is actually answered by AI itself. So this application utilizes Snowflake's Cortex Analyst, which bases itself on Meta and Mistral large language models. And this answer is actually AI providing us feedback on what are some questions we can ask within this application. So it provides some examples, and for this demonstration, we'll just say, what is the grade point average for students no longer enrolled? Now it's making a request to the Cortex Analyst, and then we're going to get a response back. And so in the response, we get two different things. We get the actual results to the question that we're asking. So it looks like the average grade point for students no longer enrolled is about 2.8. But it also provides us the SQL query. So if a user needed to run a report in the future and didn't want to have to reference this application again, they could actually save this query and run it again in the future, and then not have to refer back here. But maybe these questions aren't really answering what we are trying to look at. We can type our own down here. So let's look at the dropout rate of students for each major. So. And once again, Cortex Analyst is going to go back and give us an answer based on our data set. Hopefully soon. Okay, there we go. So it actually organized our results from the highest dropout rate to the lowest, which is another convenient feature. Again, we have this SQL query up above if it's needed for a future use case. And then we'll just do one more question, and we can actually compare two different data points. So we'll look at the attendance rate between graduated students and students who are no longer enrolled. While it's writing the answer, one important thing to note is that it's all this Cortex analyst is all providing answers based on the data as is, which is great insight into the data source, but it doesn't necessarily show us anything about maybe the future of what we want the data to look like. So as we'll see in the results, maybe the answers that we're getting don't quite align with what we would expect. Unfortunately, this doesn't really, give us any indication of why. It just provides the answers to our current data. But moving forward, Stacy created a predictive model to sort of help us answer those questions and help higher education institutions find out how they can better focus on their student retention. So for example, we see that the attendance rate for students no longer enrolled is right around 75%, versus the attendance rate of students who have graduated is 71%. So you would think that perhaps students who are no longer enrolled perhaps couldn't make it to class, maybe that's a contributing factor. It seems like the data isn't really providing that feedback. So from there, we want to explore sort of why and how we can get better student outcomes. And from there, I'll let Stacy take it away.
All right, so my name is Stacy, and the next portion of our demo, we're going to be diving into what it looks like to take one more step into that maturity journey, doing some machine learning, and also what a Streamlit app could continue to look like, some of the functionality that we haven't yet hit on today, but is still out there for universities to make the most of. So just to level set, I feel like in this day and age, oftentimes machine learning and ML can be talked about a lot and in various different ways. So for the purposes of today, I just wanted to center on this diagram just to kind of give us some language and a general flow that we're about to see in code block and in Snowflake itself. So first and foremost, when we're talking about a machine learning model today, we're going to hit on what ingestion looks like. So making sure that all that data that your university has is within one system. In this use case, we're talking about Snowflake. So we're talking about how all of that messy data in different formats can be brought together in one unified place in Snowflake. And I'm going to do a quick call out on the data ingestion. The data that we have mocked up today has been directly taken from like a demo instance of a Workday tenant. So if your institution is using Workday and you're like, how does this all connect? Please know that we are equipped to kind of help that pipeline move through from that Workday data into Snowflake, into all of these capabilities that we have shown today. So we're going to see some of the data tables coming into the model. We're also going to see the code that cleans and feature engineers all of the data. You know, at best, your data can be messy at times, and models like to have, nice scientific columns. So showing you how you can do that within Snowflake Snowpark workbooks. From there, you'll see some functions for that official model training. For today's purpose, the machine learning model that we'll be using is an XGBoost. XGBoost is just kind of one of those fancier models that aggregates a lot of the simple decision tree models all into one. So it's like really robust, and we'll dive into the accuracy and evaluation metrics of that model here today. Additionally, we want to talk about this idea of batch inference. So we know that you have students, they're all individuals, they all are going about and doing different things. And it's really impactful to understand how that student is doing and where they're at in terms of potentially dropping out or reaching graduation, really making sure that we retain them to the end at your institution. So batch inference is just kind of a data way of saying we take all of the students in your data system, we feed it through the model so that we can understand like what Scott's graduation level is, what Stacy's graduation level is, what Haley's, what Amanda's, so forth. So that's kind of getting to that individualization where you can start pulling the levers and have interventions from there. And then of course, modeling. I think a lot of times people are excited to implement their models, and we need to make sure that we are monitoring those models to make sure that they're as accurate and as precise as possible, and that there's a lot of transparency around that. We want institutions to feel confident that when a model is running on their students, they know what it means, they can clearly check in on it, and then of course advocate and act on different changes to that model. So with that overview, I am now gonna take my time to screen share. Okay. So we're first going to start with the Snowflake environment. You can see we're in the system itself. You just pulled up my Chrome browser, logged into Snowflake with my credentials. And what we're seeing right here is what's called a notebook within Snowflake. So you are able to, for any of those people who are out there who are really code savvy, really love to do their own implementation, this is where you can start coding various different things, primarily Python in SQL. So today's model is going to be using the language of Python, and we'll also have a little bit of SQL because it's interacting with the database for creating tables that exist in Snowflake. I'm going to go pretty quickly through this. Code block isn't the coolest thing to look at, so just want to make sure that we are getting through it as we go. So first and foremost, we have this first cell block. It's all just for environmental setup. So you're getting a lot of like your traditional Python packages that you're seeing. You're gonna get your active session going for Snowflake, just so Snowflake knows where to like store all of this information and make sure that it's communicating throughout the next few steps. You can see that I'm creating a stage environment within Snowflake. That's just the terminology of where we're gonna take the model that we create. We're gonna make sure that it lives in Snowflake and we can execute and run on it later on. Doing some checks to make sure it's working and that the model can be stored. Here's where you're seeing some of that SQL. This is where we're creating our master table. So we already have kind of this like workday master student table within Snowflake that has things like their major, their housing, dining plans, financial aid, how much the cost of attendance is. So you can see I'm just pulling that in right here, and then I'm actually adding some columns, some note fields that we'll mess around with later to allow someone in your institution to come in and start itemizing or like saying different interactions that they've had with the student. Here you can kind of just preview, this is what that table was that we just pulled together. So you're seeing, again, fake data here, but all attributes of what a student would look like at your institution. Okay, moving forward, again, if you can recall that slide from the slide deck, the next few steps are really going to be talking about like that cleaning step, the model building step, and the batch inference step. What you're seeing color-wise, anything that's like this blue, green, black, this is known as a user-defined function. So this is really neat in Snowflake. You can do this user-defined function, and in the middle of it, all of this red is your typical Python stuff. So this red here, you can see I'm importing some more, like I'm calling the packages, I'm defining functions to clean the data, we're dropping columns, we're renaming columns, we're converting things to days, things like that. And then it's all wrapped in this user-defined function. That function can be scheduled within Snowflake. You can see there's a calendar button here, so you could do a create schedule. So if you're ever like, I don't really have the bandwidth to every day come in here and like open up a workbook and hit run and make sure it's working, because you can make these packaged functions, you can actually just set it on a schedule and then you can get notifications from that. So makes it a little bit easier, peace of mind, knowing that it's not another thing on your plate. So as I scroll through a lot of this code, that was the cleaning and feature engineering, things like one-hot encoding, making sure your categorical variables are numeric, things like that. You can see I'm just doing a lot of checks in this, but we're getting another heavy code block. This is the defining XGBoost model. Again, the same type of thing. We're going to be putting this in a larger function so that we can schedule it, but everything in red, if you're a traditional data scientist, will look pretty familiar to you. We're splitting it out into train and test data sets. We're dropping any columns that are too granular. So we're saying like, okay, the student ID, that's like too isolated. We're not, it's going to be too noisy. It's not going to give us anything enriching about why students are dropping out or not. You can see more just specification, so making sure it is an XGBoost, it has a certain learning rate, the max depth. Again, anyone who loves Python, it's that same functionality just within a Snowflake world. All right, I'm going to keep moving along just in case you aren't super interested in the Python side. Again, you are going to be calling things throughout, so that's important. We packaged all of that Python code within a function. That function like is all stored there, but this calling is a part of like what really initiates things and gets them going. And if you're like, okay, Stacy, but how good is the model? Again, this is fake data. So the model is, as good as the data that we fed into it, but you can see that you've got this ability where you will create these models, you store them in those stage environments, you can schedule all of your functions to run at a set time, and then you're going to have all of the information. You have the ability to write it back into Snowflake as a data table. So you can see that this model that we created, you can see the date that it was run, the evaluation metric that you're looking at. So accuracy is like a pretty common one, but of course you have the world of Python libraries available to you, so you can get really granular. The value of that metric, and then the model number. So if you hopefully are maintaining your model over time, you'll have, version 12, version 50, version, whatever it may be. So that's great in terms of transparency. And then scrolling down, we talked about this before, that batch inference is all about making sure that the individuals, they have that like percentage probability assigned to them. So storing it in a function, calling the right packages, creating different functions to do that, calling it once it's created, and then checking it in this table. So you can see at the student ID level, the prediction 0 is if they're predicted to drop out. You can have like the actual like decimal for the percentage of if they're at closer to 1, that means they're closer to graduating, closer to 0, closer to dropping out. This predicted at is just a date time. It's what the computer really resonates with. But of course, at your institution, if you don't speak computer time, we can format it so that the table is a little bit cleaner on your front end. Okay, so that was a lot of Python, but just know and get excited that if these things are interesting to you, we're happy to help, happy to explain more. It doesn't have to be a certain XGBoost function. It doesn't have to be, certain evaluation metrics. A lot of this is customizable, and we want that to be just really hit home because we know you all are unique institutions. All right, I'm going to check my time. With my last bit of time, I'm going to show yet again another Streamlit app. Streamlit app, you can see we're in the exact same interface as we were before in Snowflake, just a slightly different area. We're in that app section, Streamlit apps. And what we're going to be seeing here is, I'm just going to run it to make sure all the data is working. This Streamlit dashboard is specifically set up to really allow institutions to pull levers and understand what does it mean for their students that are potentially going to drop out? What are the ramifications financially to the student? What are the levers they can pull? So first and foremost, you've got your dashboard, a little bit of level setting, a little bit of room for some backstory for people to just all get on the same page. We begin the dashboard with this ability to filter into your different subsets of your population. So if you recall, our previous Streamlit dashboards by Scott and Amanda were all about student populations that had already been decided. They had already officially dropped out or officially graduated. So in this dashboard, because we're doing a lot of predictions on where current students are at, you're going to have the ability to see, like, if you're in student, you can filter to see your in progress students, the ones that are predicted to drop, the ones that are predicted to graduate, or of course, there's some ability to actually pull back and look at all of the ones you actually know. So you can really start to slice and dice the way that you want. For the purposes of today, we'll just see the financial ramifications for the students that are predicted to drop. So you can see, this is a pretty large number. So you're looking at about $9 million on the line if all of these students end up not completing their degree. You'll also be able to see the thousands of dollars that you're already giving out to these students for financial merit aid. So kind of that push and the pull on that end, and then the work study amounts that those students that potentially might drop out are pulling down on. And then just the second row, same numbers you're looking at, just by averages, so it's like the per student costs. This is just another way to make sure that people can really hone in on different interesting attributes. So again, this is just the art of the possible. You could put any attribute. It doesn't have to be race or gender. It could be whatever column you have in your data that you're interested in breaking down on. But you can click and you can add different things to really start to see some journeys, and then it'll populate the graph accordingly, giving you kind of where you're most at risk of graduating or dropping out, those bar charts. This is personally my favorite section. So this next section is all about just building out functionality that allows people who aren't necessarily as interested in bar charts, but are interested in making like meaningful impacts on a student level. So this section is called Understanding the Student Level Journey. And you can see like at the bottom here, you've just got like this whole table of your students that you can scroll through. You have all of their like information all in one table that you can investigate at your leisure. For today's purposes, we're actually going to really hit on this idea of like having notes within your data set. So you saw all the information before. You could see that this student is, on campus housing, has a student aid index of this number, is on the 49 plan for dining. And then you have notes here, and you're also going to notice these little pencil icons up at the top. So you could come in here and say, you know what, like C. Kent, like I know that he didn't make that note, I did. So you can click on it and you can actually just be like, okay, I'm going to update this in our data source to make sure that it's actually showing the correct person who initiated that student record. Same thing here. Let's say I met with this student and we talked about career outcomes. I could just directly interact with this table and say like 331 met with student and talked about jobs. And I can hit enter. And it's just actively updating anything that has a pencil in here. And again, this is all customizable. So you as an institution can decide what columns in your backend data source this user interface would be able to edit in real time. And again, you can see there's just like a save change function that you'd want to hit. And then this is what's really fun too. So if you met with 3 students at one time, so you know that you met with this student, you met with your student that was 256, with the 1208, you can click multiple at one time. It's going to show you all those students. And then we're going to scroll over to notes just so you can see what's happening here. And you can see like, oh, all of these students I met with because they were at risk of dropping out. They're all predicted at 0. None of those percentages are great. And right now their note is, various things. One of them dropped chem. One of them tried to attend a graduate fair. But I had all 3 of them together. I could say like 331 met with students, getting them tutors. Because I know that was true for all of them. I need to make sure that the system knows that I added this note. So I'm going to hit enter here. I can save this note and it updates for all of the students at once. So it saves you a lot of time. You can just like look up all of the students that you like need to update, and then boom, it updates the created at date, says, the name that you entered, and then the notes associated. Okay, and then lastly, we talked about transparency and we know how important it is. And so you can even build in either in this app or in a specific model evaluation app, you can start to really hone in on those tables where you're like, how much can I trust this model, or what version model are we on, or we started a new academic year. When was the last time we trained this model? You can start to like show all of the metrics that you're interested in. You can remove them at your leisure, and then see again, the date that it was trained, those metrics, the value, and the version. All right, so with that, I'm going to pivot back to Scott for us to wrap up today's meeting.
Thank you, Stacy. So at this time, I think we can go ahead and open it up to the floor for any Q&A we have. And we'll have Vanessa here, and she is going to help facilitate that Q&A for us.
Awesome. Thanks, Scott, and great job, team. We had a few questions come in throughout the presentation, so we'll go ahead and get started with those, and then anyone else who has questions, please feel free to keep dropping them in the Q&A box. All right, so our first question that came in was what reporting tool is used to generate these graphs? And based on the timestamp, I believe it was during Haley's presentation, part of the presentation.
So I'm not sure how, like, what graphs within the NLQ app, but within the dashboards, and I think within Stacy's app, all those graphs were made within Streamlit itself. So we didn't have to use a separate reporting tool like Power BI or Tableau. Those were all done within Streamlit, within Snowflake.
Thanks, Haley. And if anyone needs clarification on that one, please feel free to message us or put another question in. Okay, so the next question says, how often should you feed data into Snowflake as a general industry standard? Would it be daily? Anyone want to take that one?
Yeah, I can take that one. It's really going to depend on what type of data, we're bringing into Snowflake. If it's something like future applicants, as we receive those, we're probably going to want to ingest that data into Snowflake on a daily basis, something that changes frequently. But if we're thinking about maybe final term grades that aren't going to update frequently, you could set up your data pipelines or data ingestion to, only ingest that after a semester is complete. So it really is just dependent on, what data is being ingested and, how often or up to date your reporting teams need that data.
Thanks, Scott. Okay, next question. Does the data ingestion design usually include the functional users as to what to ingest and the relationship between different data points?
I can speak towards that one. So that's a really good question. I think like as consultants, we obviously always want to lean on the expertise within an institution. So we do really welcome like collaboration and thoughts in that. I would say from a data perspective, the more raw data that you can have in your systems, the better. So pulling anything that you can in is great. And then the power of kind of machine learning and things of that nature, we can like run statistical analysis to really understand the relationships between different things. But in terms of just like data schemas and making sure that it's fitting properly and the aggregation is correct, of course, yeah, like we're going to want to meet with whoever the subject matter expert is on either like collecting the data, creating the data, and definitely just understanding like what the data is like currently being used for at the institution. So that's a pretty long answer to say that, it's a give and take of a lot of different things, but of course, in terms of like bringing data into a system and making sure that like your Snowflake environment is set up well and able to like join across different tables, we would of course rely on expertise on what the data is telling us.
Thanks, Stacy. And then a question came in towards the tail end of your section, and maybe this person got their answer when you were speaking, but they wanted to know, is the edited value going to be overwritten by the next ingestion?
Yeah, interesting question. So the way that like the user interface works, it's the same as just like if you were doing like an update or an insert into a table. So as long as you're hitting those save buttons, that becomes like your new source of truth. And then if you are saying like the next day you would schedule a run and that table is going to be updated, the overwritten stuff will hold true as long as that record didn't have another update to it. So it will always be like reflective of whatever like the most recent saved version is. So if that was in the UI, it's going to hold true to that value unless something in the data ingestion says like someone else later on met with that student, and then it can like look at that like created by stamp and kind of reconcile from there.
Awesome, thank you. All right, looks like we have time for just one or two more questions. This question says, can you go more in depth about the capabilities and benefits of Streamlit? And maybe Scott, you can take that one.
Yeah, absolutely. So at its core, Streamlit is really just an open source Python library, and Snowflake makes it super easy to integrate these two together. As Stacy was showing, you can develop and code your application in a side-by-side view. So not only can you make updates to the application, but you can see those changes to the application take place in real time throughout the process of developing your app. And really, Streamlet's kind of known for being a go-to for being able to customize web applications for data visualization, data science, and analytic purposes.
Thanks, Scott. All right, we have time for one more question. If anyone has any other questions, please feel free to put in the chat and we'll reach out to you, or reach out to the Caresoft team and they'll point you in the right direction. But this one says, can you use third-party tools and applications for data visualization and reporting with Snowflake? And maybe Amanda, you could take that one.
Yeah, I can take this one. So Snowflake integrates well with other data tools. Besides Snowflake, Snowsight, and Streamlit and Snowpark, you can use Snowflake's business intelligent partners that natively connect to Snowflake. So this includes Adobe Campaign, Tableau, and Microsoft Power BI, just to name a few. And if you want to use a third-party application for data visualization, then you will need to configure Snowflake connection details just to leverage the data on Snowflake for your reporting purposes.
Thanks, Amanda. All right, 1 minute to go. Thanks so much to all our presenters today, and thank you as always to our great partners at Caresoft for letting us present.